Hey guys, it's Miss Aguilar again. This is our third video of the three video series, I guess you can call it, for the graphical representations of constant acceleration. And we left off in the last video covering the position time graph, velocity time graph, acceleration time graph of a positively decreasing slope. And before I left, I didn't get a chance to just talk about the signs on acceleration and velocity and what that means as the object, and what that means about the object and whether it's speeding up or slowing down. Okay, so since we have a positive and a negative um, velocity and acceleration, so what that means is that they're opposite signs, right? So we have opposite signs. That means that our object is slowing down or decelerating. And if you remember before, if we had same signs, same means speeding up. All right. So then I went ahead and I just filled in the motion map before I started the video, and I did the same thing I did the last time. So I set up a legend and I filled that in, and then I went forward and I did our motion map. So how did I find the initial position? Well, I looked here on the position time graph and it's 0. I looked at the velocity and saw that it was positive and decreasing, and the acceleration was negative and constant. So the blue arrows represent velocity. It's positive, so they're pointing to the right. It started at 0 meters, so that's why the first dot is at 0 meters. And it's decreasing, that's the velocity. So we started off with a long velocity arrow, which is in blue, and the next velocity arrow got smaller or shorter. And then the third velocity arrow is shorter than the previous two. Now, our acceleration arrows are drawn here in red, and they're negative constant acceleration. So each of these red arrows, which is the acceleration arrows, are the same length. That represents a constant variable, so our constant acceleration. And they're pointing to the left because the acceleration is in the opposite direction of the velocity. That's why we can say that this object is slowing down. Okay. So now instead of talking about a positive decreasing slope, let's talk about a negative decreasing slope. So what will that look like? It'll look something kind of like this. And how do we know it's decreasing? Again, you're going to go through and do your tangent lines here and see that it starts off vertical or more vertical than it ends. So it's slowing down. It's decreasing. Okay, so what can we say about the slope of our position time graph? Well, we can say it's negative, right? Because it starts at a positive position and it gets to a closer and closer to the origin. So we have a negative changing slope on our position time graph. That slope can be replaced with velocity because the slope on a position time graph is velocity. And then we can be even more specific. Instead of saying that it's changing, we can be specific how it's changing. Is it increasing or decreasing? Well, it's decreasing. So how do we show a negative decreasing velocity? Well, the negative tells us that our velocity line is going to be on the negative side and that it is decreasing. So that means that it is starting at a greater negative velocity and going, well, let's just call it to 0. Okay? Now, let's talk about the slope of this line. So the slope on the velocity versus time graph. Well, first, we know it's constant, right? Because it's changing at the same rate each second. So it's constant. And we can say it's positive because it starts at a negative and it gets more and more, it gets closer to 0. And, I know it's not that easy to see, so in just a second, I'll kind of explain how that is a positive constant slope, but give me just 1 second. So what can we say about acceleration from this velocity time graph the slope of the velocity time graph? Well, we can say it's also positive constant acceleration. How do we know that? Because the slope on a velocity time graph is acceleration. So how do we show a positive constant acceleration? Well, it's on the positive side of acceleration, and this line means that our acceleration is not changing for every second that passes. All right, so let's talk about the signs on our velocity time and acceleration time graphs. This is a negative velocity because the line's on the negative side. This is a positive velocity or acceleration because the line is on the positive side of the acceleration time graph. So what does that mean? Well, we have opposite signs. Opposite signs means that it's slowing down or decelerating. Slowing down, or you can say decelerating. All right, so some of you are probably wondering, wait, how did she get a positive from this? Well, just do the math. If we call this negative, 20 meters per second, and this is 0, right? Because it's now at a velocity that's 0. Of course, it could have some sort of time. Let's call the time 5 seconds, and this is 0 seconds. Now, if we were to do the slope or calculate the slope of this, the top number would be the final, which is 0, minus negative 20 meters per second over 5. I got that because I took this and that. Now, what is a negative times a negative, or what is a negative and a negative? It makes it a positive. So we would end up with 20 over 5, which would be 4. So that positive 4 would represent the slope, and that slope would then be positive 4 meters per second squared, and that would represent acceleration. All right, for those of you who are wondering about it. If you weren't wondering about it, well, still don't worry about it. Okay, so here we go. Let's do our legend. Initial position, velocity, acceleration. Where do we go to look for our initial position? We go to our position time graph. It's positive. It starts off here, a positive position. And then we have a negative decreasing velocity and a positive constant slope. So positive initial position, negative decreasing velocity, positive constant acceleration. So we're starting in a positive position. Our velocity is going to be pointing to the left, and it's decreasing. That means it's starting off big. Sorry, those are supposed to be straight lines. And it's getting smaller and smaller. I told you before, and I'll tell you again, I have trouble making lines to the left. It's really weird. All right, so now about our acceleration arrows. They're positive and constant, so that means they are pointing in the opposite direction of opposite of the velocity arrows, so that means they're pointing to the right. And all of the acceleration arrows are all the same length because our acceleration is constant. All right, let me just do one last thing before I let you guys go, and this is just something that's going to help you remember what the slope of each of the graphs represent. So if we have a position time graph, the slope of that line of a position time graph represents velocity. Now, the slope of a velocity time graph represents acceleration. All right, so position time graph slope, velocity. Or velocity time graph slope, acceleration. Now, in a couple weeks, maybe sooner, we're going to figure out how to take an acceleration time graph, calculate the area under the line, and that will tell us velocity. If we take the area under the line on a velocity time graph, it'll tell us position or displacement. All right, this side, the green side, you don't have to worry so much yet, but this blue side, you should definitely know that sort of stuff. Okay. All right, so position, time graph, slope, velocity. Slope of a velocity time graph, acceleration. All right, you guys, well, hopefully this has been really helpful. This is the final video of this graphical representations of constant acceleration. I'm going to do another video where it has those stacks of graphs, and you guys can just kind of glance at the different graphs and be able to see what each of the velocity time graphs and position time graphs all mean. So that's the other handout, and I'll do a short video on that as well. All right, email me if you have any questions, and have a great weekend.